In this lesson, we introduce you guys the concept of normal distribution, which is just calculating the probability of a situation. Here, a normal distribution usually follows what's called this bell-shaped curve or normal curve. And here, notice how it's very symmetric. So keep in mind that the total area, so this entire region underneath the bell curve or our normal curve, is always going to add up to 100%. So this is going to include all of the data points for that probability. Then the empirical rule is what we would use here. So anything that follows empirical rule, we're going to use the bell curve. So, and that tells us that 68% of the data is going to lie within one standard deviation. So what I mean by that is, if you look at the curve, now mean is actually going to be represented by mu here in this case. So remember, mean can be used as that X with the bar, but mean can also be represented by mu. So here, this is the mean. So if you think about it, right, mean is in the middle, that is your average. So then remember, sigma always represented the standard deviation. So see how here it says mu, so that's your mean, but then one standard deviation above and one standard deviation below. So notice here from this line here to this line here, that is one above, one standard deviation above, one standard deviation below the mean here. And if you notice, what percentages are here? Well, they add up to 68%. So that's what that means here, that 68% is within one standard deviation. So then 95% of the data is two standard deviation. So here, if you go to the next line over, it's a little off, but two standard deviation. So two lines over and less than. So these, if you were to add up these percentages, which include the 68%, but then plus 13.5 and 13.5%, which is 27. Here now, you have 95% of the data, so two standard deviations above and below. And 99.7% of the data lie within three standard deviations. So here, that third line here is 99. So again, this is the third. So this is our three above and three below. So this is the 95%, right? But now plus 2.35 plus another 2.35. So if you even wanted to add that, you do end up with 99.7%. So here, again, one standard deviation is 68%. Here, two standard deviations is 95%, and three standard deviations is 99.7%. Then, of course, anything outside of three standard deviations above and below, you're now in the extreme values, which there's your other 0.15, 0.15, which is that 0.3% that's missing to add to make this 100%. So like looking at example 1, it states how here we're talking about our fully grown white oak trees are normally distributed with a mean. So here's our mu. Mean is 90 feet and standard deviation is 3.5. Remember, this is your sigma. So we're going to use the empirical rule to answer these questions. So the first thing I'm going to do is I'm going to go ahead and use my bell curve and identify, because we're using empirical rule. So the mean, we're starting at 90. So this right here in the middle is our 90 feet. Then remember, it stated that the standard deviation is 3.5 feet. So that means all we're doing is now adding one standard deviation. So if the standard deviation was 3.5 feet, so one standard deviation would be 93.5. All you're doing is adding the 3.5. So then 2 standard deviations, add another 3.5, and now you're at 97 feet. Then here you're at 100.5 feet, and anything above is going to represent 0.15%. That means going the other direction, you're now just going to subtract the 3.5. So like here, one below, this is 96.5. So then subtracting another, you're now at 93. Then here, subtracting another 3.5, and now you're at 89.5. Then, of course, anything beyond 3 standard deviations, you're in that 0.15%. So now that we have our labels using the standard deviation, now let's go back. What percent of the oak trees are between 86.5 and 93.5? So 86.5, which is as we're looking, and then so sorry about that, guys. I just realized I made my mistake. That was supposed to be not 96.5, but 86.5. Sorry about that. So here, so subtracting the 3, so 86.5, then 83, and then here is 79.5. Sorry about that. Now let's go back. So we're looking at 86.5 to 93.5. So 86.5, which is here, to 93.5, which is here. So notice we're talking about this line, which is one below, and here to this line, which is one above our mean, which includes, so that is 34 plus 34. Remember, right, that's your 68%. So 68% of the data, or 0.68. That is the probability or percent of getting a height between those two. So at what percent of the white oak trees have heights less than 97 feet? So less than 97. So here now, so let's erase. So 97 is here, but we're talking less than. So we're talking about starting at this value here, right, on our curve, which is 2 standard deviations below, and all less than. So we're taking these percentages and we're looking into how much of the data is here. So there's 2 ways you could solve this. You could just add up all of these percentages, right? Or we know that all of these add up to 100. So you could just have 100, then minus the 2.5% that was not included. So that's why here, from subtracting, so 100%, right? Minus the 2.5 that was not used. So that's another way that you could also get that. And here you end up with, sorry about that, 97.5%. So now at what percent of the oak trees have heights of at most 83? So at most 83 feet. So here, let's go back. So at most 83 feet. So we're going to identify our, whoa, hello, sorry about that. I don't know what just happened. Here's our 83 feet, but this said the percentage that would be at most 83. So that means 83 is the most, at most. So we're starting at this line here, 2 below, and again, going to the left here, at most. So those 2 percentages are what we're going to use, which is 2.5%. So now here, 95% of the data falls between which 2 values? Well, remember, 95% means we were talking about, according to our empirical rule, 2 standard deviations, above and below. So again, we're identifying the 2 percentages, or so our percentages are 2 above and below. So here's below, 2 below, and here is 2 above. So we're talking about from 83 to 97 is 95%. So here, oops, sorry, I went the wrong direction. So that's why the answer was D. So go ahead and pause the video and try this U-Try on your own. And here we go. So here, the Atlanta Braves have a mean batting score of 250. So that is our mu. Then standard deviation of 20, that is our sigma. So here that means when you are talking about the normal distribution here, normally distributed, we're starting at 250. And then one standard deviation was 20. So adding 20, you're now at 270, 290, 310. Then subtracting 20. So now here you're at 230, 210, 190. So now you could go through and answer these questions. So what's the probability that the team has an average of over 290? So looking at 290, which is here, notice how this is at 2 standard deviations above. And we're wanting to know greater than. So that is these two percentages, which is 2.5%, or the probability is 0.025. Again, remember, right, this is the same as converting your percentage to a decimal. So dividing by 100 or move it 2 places to the left. So then what percent of our players fall between 210 and 270? So 210, which is here, and 270, which is here. But to solve this, you had to add up these percentages. So 13.5 plus 34 plus 34. So here's your 68, but plus the other 13.5%, which is why you should have gotten 81.5%. Or if you also, that says percent, but if you wanted to also practice, then that is 0.815 for that probability. Then the next, what percent of Braves players have a batting average of at most 230? So at most 230. So here is 230. This is the most. So that means we're going all less than. So we need to include 0.15, 2.35, which is 2.5%, as well as the 13.5%. So here, when you add those together, you should have gotten 16%. So now, which 68% of the data falls between which two values? So if you recall from empirical rule, 68% is one standard deviation above and below. So looking back here, one standard deviation above and below here is 230 to 270. So that's why you should have gotten B. Now, example 2, just to show you how we're going to solve this and why. Because this says that our test scores are normally distributed with a mean. So here's our mu of 75 and a standard deviation of 8. So if I wanted to go ahead and start identifying, right? So I could, so just to show you, I've got starting at 75 and standard deviation of 8. So here adding 8, so we're at 83, 91, 99, and subtracting 8. So 67, 59, and 51. But if you look at the first question said that we need to estimate the probability that a randomly selected student scored between 71 and 75. Well, notice how 71's not here. 71, we would have to estimate it somewhere from here. So 71 to 75. So here we know 75 is our mean, but we don't have 71. So this problem does not follow the empirical rule. So because this does not follow the empirical rule, that is why we are now going to have to use the graphing calculator. So here we can already, when we do this, it's going to ask us for the lower bound, upper bound. We already have our mean, which is 75, that will always be given to you, and standard deviation sigma, which will also be given to you, which is 8. So here, the lower bound and upper bound. Well, in this case, this one's nice because the lower bound and upper bound are given to you. The lower bound is 71. The upper bound is 75. So this is the information that we're going to put in the calculator. But in order to do that, these are the steps that we're going to follow. So here on the calculator, see how we need to get to this distribution here? So DISTR. See how it's on in blue? So in the VARs right next to clear. So see how clear right next to it. But the DISTR here, right, is in blue. That's why this step here says that we need to, we need to actually press the second VARs to get to that distribution here in blue. So we're going to press the second and then VARs to get to the distribute. So that's your screen. Now, we don't want normal PDF. We want normal CDF. That's why we're going to option 2. So you need to arrow down to option 2, the normal CDF, then press enter. So now see, here's that information. Now we can just go ahead and clear that and put in our lower, so 71. Then arrow down to our upper, which was 75. Then here, it will always start off with that 0 and 1. So let's clear that. And we're going to put our mu, mean 75, and sigma, which was that standard deviation, which is 8. Now just enter and enter. So see how here now it gives us, just to make sure, right, that we put those 4 pieces of information. And now we press enter again. And that is the probability, 0.1915. I like going 4 decimal places just to make it as accurate. So here, 1915. So 0.1915, that is the probability. So here, let's do the next one. So again, higher than 80. So again, we can already tell if we're starting at 75, but standard deviation was 8. Higher than 80. So this does not follow the empirical rule. So again, we're going to have to use our calculator. However, we need to first, let's go ahead and identify. Same again, the mean is 75 and standard deviation is 8. But now we need to figure out what's the lower and upper bound. We're talking about here scoring higher than 80. So that means 80 and above is what we're talking about. So we're going to look at 80 as that lower bound because we need higher than that. So 80 is the lower, and then we're going greater. So here we're just going to make things accurate in the calculator, I like using 1 million. So if we need to use a lower, then we're going to put negative 1 million. So we're going to put these values now in the calculator. So let's go ahead and go back. So we need to get to that second VARS. So second VARS, go down to normal CDF option 2. Now this is all the same stuff from before. So I'm going to clear that and put 80. Then here, arrow down, I'm going to clear that and put 1 million. So 1 and then 6 zeros. Now we already have the 75 and 8. So now I'm just going to press enter, enter, enter till I get down. There's our values. And here is our probability. So approximately 0.266. So with our rounding. So 0.266 is the probability. So now let's go to the last. Scoring less than 87. So less than 87. So again, mean and standard deviation are the same. Now we're talking about less than 87. So 87 is, if you think about it, the upper bound now, right? Because all the scores are less than this. So 87 is the highest. So 87 is now the upper bound. That means we're going less than that. So negative 1 million. So here we go. We're going to again go to second VARS, go down to option 2 for CDF. Then here we now need to put negative 1 million. Then here we're going to clear that to put our upper at 87, and we already have the mean and standard deviation. So enter, we have our information here, and enter again. And that is the probability, 0.9332. So here, 0.9332. That is the probability. So go ahead and pause the video and try these three for this situation, given that the average of 432 miles per tank, Jamie can drive her car with a standard deviation of 36. And here we go. So notice, remember, right? Average, that's your mean. So that is our mu. So 432, and standard deviation, that is your sigma, which is 36. So here we know that no matter what, that is not going to change. So I'll just go ahead and fill that information in. So for the first one, you had to estimate the probability that she would drive more than 450 miles. So if she wants to drive more than 450, that would be the least amount. So you should have set 450 as the lower bound and then 1 million as the upper bound, because you're going more than, greater than. And so here we go. So again, to put this information in, let me go back, quit out of that. So again, you have to do that to get to distribute. So second vars, then go down to CDF. So now we've got to put in, so here 450, our upper is 1 million, the mean 432, and standard deviation, which was 36. Then enter. And here's our probability. So probability is 0.3085. So 0.3085. So now here, the second one, you were looking for the probability that she would drive between 400 and 440 miles. So that is the lower and upper bound because it's between those two. So between 400 and 450, sorry about that, 440. So here we go. So again, second vars, CDF, then you should have put 400, and then here, 440. Same information, so I'll just press enter. And you should have gotten 0.4009. So 0.4009. So now here, we're going to estimate the probability that she will drive no more than 375 miles. So no more than. That means 375 is the highest. That's the upper bound. So 375 is your upper because that's no more than that. So now here, the lower bound you should have used was the 1 million. So here we go. Second vars, CDF. Then you need to set it up. So negative 1 million. Our upper, 375. Same information. So now we just press enter. And that is the probability, 0.0566 or 0.567. So 0.0567. So now go ahead and pause the video and try these three. So this is a mixture of the two. So it could follow empirical or it could not follow empirical. Just remember, if it doesn't follow the empirical, then you have to identify your lower and upper bound to put in the calculator. And here we go. So for the first problem, you should have noticed that this did follow the empirical rule. We are using the curve. Because here the mean you start at, your mu, is 51,000. The standard deviation, your sigma, was 6,000. So if I were to start at 51,000 in the middle, right, that's your mean, then add 6,000, you're now at 57,000. Then add another 6,000 and you're at 63,000. Notice that that was the upper bound. Then here, if you were to subtract 6,000 to go one standard deviation under, you are now at 45,000. So this did follow the empirical rule. So I'll go ahead and set that up, but using the curve. So again, here we have 51,000. One standard deviation was 45,000. One standard deviation above is 57,000, and 2 is 63,000. So notice how here we're going from this line here, one below, to 2 standard deviations above. So we are including these 3 sections, these 3 percentages, which are the 68% plus the 13.5%, which is 81.5%, or as a decimal, 0.815. That is the probability. Now in number 2, this one did not follow the empirical rule. You had to set up what is the lower bound, what is the upper bound, what is the mean, what is the standard deviation, because the mean was 20 and standard deviation was 4. So here, if I wanted to start at 20 and then add the standard deviation, I'm at 24, 28, and 32. Notice how we're talking about, again, yes, it says normally distributed, but what was the probability to expect to wait no more than 30? See how the 30 minutes does not follow empirical rule. So it's in between. So that's why here you had to set up lower upper bound. So mu or mean was 20 minutes. Your sigma standard deviation was 4 minutes. No more than 30 minutes. That means 30 was the upper bound because you're going no more than that, so no higher. And the lower bound was negative 1 million. So going to your calculator, again, second vars, going down to CDF. So here, oh, well, I've already got that from the previous, so I'll leave that negative 1 million. But here we have 30 with our our mean, which is 20, and our standard deviation was 4. So you should get 0.9938. That is the probability that a person will wait no more than 30 minutes. Then question number 3. This you are going to use the empirical rule, the curve, because here we've got 95% of the data, which if you recall, following empirical rule is 2 standard deviations above and below. So we are using the empirical rule here. So to set this up, we have our mean. So we're starting at 500 days, standard deviation of 61. So we're going to set it up starting at 500 and standard deviation of 61. So 561, and then here add another 61, and you should be at 622. Now you could keep going, but remember, right, all we need is 95%, which is 2 standard deviations above. Now let's go the other direction to go to 2 standard deviations below. So now 500 minus 61, so 439, and then subtract another 61 to get 378. So here, 2 standard deviations below, 2 standard deviations above. That's why 378 to 622 was the answer, which was C.